Wow, this is amazing from up here. Thank you for coming. My talk will be about the remote journey that from a handful of engineers we were to more than 100 backend engineers. Our monolith saw everything, started with like the Phoenix init, and now we have more than 3 million lines of code. We will talk about how we scaled our development processes over time, some of the lessons we got along the way, and also the improvements we had to get to make where we are today. So, who am I? I'm André, working at Remote's FinTech product area. I'm a staff backend engineer. You can find me on GitHub. And I'm also a parent. I've been using Elixir since 2016. And here I'm aliasing the dynamic supervisor as life. So you'll see where I will get to. I'm starting a new supervisor called André. Then in 2015, José was born, and I became a dad for the first time. Then came Luis in 2019, and then Pedro. I was mostly happy with the dynamic supervisor, although it was a bit biased, right? So we decided to give it one more shot for a baby girl. Maybe this time it would be what we would get. And we got an OK tuple, so everything worked perfectly. But when we checked its length, we kind of got lucky. So please let me know if you have any tips on how to be a dad of 5. I think I might need to open a bug in GitHub. So there's something happening with this dynamic supervisor. Moving on, let's talk about remote. So we started out with a mission to help out companies to compliantly hire employees from all around the world. And nowadays, we also provide like an integrated suite of products. You can use us to do expense management, performance management, hire contractors, time off, equity, everything else that you think can be and should be done properly with regarding HR, we are there for you. Big shout out to Remote for sponsoring the conference and for contributing to the Elixir ecosystem whenever we can. Let me show you a picture that shows like where we are today. We can see in blue, yellow, and red the number of backend, front-end, and other folks, other means, team leads, engineering managers, SRE, QA. So from the handful of engineers that we were in 2020, we are now more than 100 backend engineers, okay? Until 2023, we had roughly the same number of backend and front-end folks, but we had to hire much more backend folks because we needed to not only deepen the existing features, but also to build additional products. And the code grew with the team, okay? So you can see the number of tests, Elixir files, and also modules in light blue, green, and orange, okay? And those 82,000 tests that we currently have were counted with the regex, okay? So it's not counting tests that are being expanded with macros. So when I was coming in the train, we have more than 93,000 tests currently. So it's interesting to see that tests are growing at a faster pace than the current code that we have. In my proposal for this talk, I said I would be talking about 2 million lines of code. But since then, we now have 3 million lines, okay? This gives us a ratio of 30,000 lines per backend engineer. Interesting enough, SEC tells us that JSON is our second language, and this makes sense for us because JSON schemas are really important for what we do. We have a very cool blog post about it. Check, please, if you are interested. So yeah, let me highlight some of the things that we got and we had to build during this journey. It's crucial to mention that it takes a big village full of bright people, right, to get to a code base this size that still allows people to be productive and continue to ship consistently over time, right? There are some folks who left in the meantime, but it takes very bright, a lot of people to build what we built so far, okay? I participated in some of these situations, obviously, but I can't take any credit for the great work all my colleagues have been doing on a day-to-day basis. And I think it's also important to mention that José Valim is our advisor, and he has been always available to help. His suggestions and contributions have been crucial along the way, and his attitude is a great reminder, right? How one can lead by example in a very kind and brilliant way, as he always does. Let's take a look at our architecture, what it looks like today, how it started, and some of the tweaks we had to make along the way. We started with a React monolith on the front end and the Elixir monolith on the back end. Okay, we call it Tiger. The front end is served by an internal API that Tiger provides. And nowadays, we already have some satellites, I call them, around the monolith for specific products. They started as separate services because we expected from the get-go like very different load patterns than what we were seeing on the Tiger monolith, and also due to some compilation issues that we have that basically we wanted those teams to not suffer from the monolith, okay? These are all Elixir services. Each one has its own database, as we will see next. Since the very beginning, we took inspiration in solid patterns, principles, right, to establish one of the foundational guidelines that we still have in place to this day. Okay, we have vanilla Phoenix controllers. We delegate to handlers the work that needs to be done. These handlers orchestrate different services to achieve a given business outcome. And finders should expose a single find function and shouldn't have any side effects. Basically, use them to fetch stuff from the database. And values are kind of agnostic structs that we use as return values, so you can pass one to a Phoenix view, and it will render the data for you in a given way. When I joined in 2021, these guidelines were already in place, and I'm not going to lie, they felt a bit boilerplatey. But after a while, like, you get used to it, and I think like it provides a consistency that sometimes we take it for granted, but it's very cool to grab the code from any team and still feel comfortable around it. So this consistency, I think also, if you don't fully agree with it, enables future refactors in the future. So if you are really want to throw it out of the window, you will be able to more or less easily do it. Later on, when we grew the number of teams and domains started to emerge, we started to see handlers of given domains reaching out to services on parallel domains, resulting in very tightly coupled domains, application flows becoming harder to follow and maintain over time. And this had the potential to reduce teams' velocity, to cause slower ramp-up times for new hires, so we had to do something. And that's where we introduced the concept of domain APIs, okay? Think about them as like the official entry points to your domain, your public API that you should curate, document, and this will provide like the full menu of stuff that your domain should expose, right? To make sure that no other domain would reach out to internal domain stuff, we adopted the boundary library by Sasha, making the domain APIs the only entry points that could be used, okay? These big decisions at remote are always introduced with an RFC document that everyone is encouraged to participate. So we adopted the boundary, but the rollout of it was not smooth sailing, okay? We saw some teams that just created a boundary to comply with the guidelines and moved on. And so they didn't necessarily invest or thought about the actual public domain API they wanted to expose. And this led in some cases to too small boundaries, causing, imagine even a simple feature to cross a lot of boundaries, so a lot of boundary violations. And this was a very bad developer experience because folks were used to combine and mix and match everything and open their merge request and call it a day. So boundary worked as advertised, right? But people complained a lot, especially querying data, for instance. Our guidelines recommended not exposing the active schemas. So people had to reach out to the domain APIs to enrich the data that they were using, and it was much more cumbersome compared to what they had. Compiling with boundary was also slower because it required a full recompilation, and for our application it means like 10 minutes. So we ended up only checking boundary violations on CI, but this delayed the feedback to a very late stage in the development process. So people weren't super happy. So fast forward to today, and we revised how we are using it, right? We kept the main boundaries that we all agree on. So the remote one has common stuff, Tiger Web, some specific boundaries that teams own and that were created from the get-go. So payments core, billing core, and all those smaller boundaries that we had were removed so that people wouldn't feel the same pain that they were facing before, okay? We also changed the guidelines to be, for a boundary to be opt-in instead of strongly recommended. So nowadays teams can pick it if it really makes sense for them. And it solved the main pain point that we had about composing queries. We have been talking with José Valim to see if we can do like a kind of a lighter boundary check that wouldn't require a recompilation, maybe relying on mixxref, a couple of conventions. Imagine a code owner's file that you could use to somehow say that what's allowed and what's not. But this is in the still embryonic phase, so stay tuned. To help with the coupling between domains, we also introduced a mechanism called hooks. So in this example, the public API service will create a company manager, and then it needs to update the sign-up source. Okay, so it reaches out directly to the accounts domain to do it. The problem with this is that the accounts domain itself might be doing a lot of stuff there, we don't know, that could impact the performance of the public API. So instead of reaching out directly to a domain, we can use hooks to allow the public API service to just say that something happened without having to actually execute the side effects of the thing that happened. So here we are using the trigger async flavor, which basically will execute each consumer in a given background job. And so this way, it doesn't affect the public API response. Obviously, we can do it here because we can afford eventual consistency, so we don't require the consumers to finish before returning the response to the customer. If you need strong consistency guarantees, you can always use the synchronous trigger function, okay? This one will execute inside the same transaction at the expense of a longer running transaction, but it gives you the strong consistency guarantees that we had before. So with boundary and these hooks, our goal was to reduce coupling, to basically reduce the number of things that engineers need to have on their minds when they are developing, and hopefully help teams achieve a higher velocity. I want to talk to you now about like how we deploy things. Currently, we have 2 deployments of the same Tiger application, which we call Tiger API and Remote API. This is exactly the same application, but it starts different supervision trees depending on an environment variable. Okay? In this setting that we currently use, Auburn background jobs are still executed by the Tiger API deployments. Okay? Just a quick note, Auburn is a job processing library for Elixir that in our case is backed by Postgres. And we have been observing that some heavy Auburn jobs can affect our internal API since they share the same Kubernetes pod resources like CPU, RAM. And so we also saw some DB connections kind of timing out when the system is under load. So something needs to be done. So here, like, this is basically what we currently have. We have a bunch of Tiger API pods. There is a load balancer in front that is not represented. The user establishes a WebSocket connection with one of the Tiger API pods, and it's the internal API that is also served by the same pods. And within each pod, we have also the Auburn workers executing the background jobs that we have. just a note, we need to cluster the different nodes because we want for our open jobs running on any node to be able to push notifications to the user. And so basically, with the nodes connected and with the help of Phoenix channels, we are able to route the message to the user. The plan is to introduce a new Tiger Workers deployment, and this Tiger Workers deployment will only be responsible for executing background jobs. This way, the allocated resources that we assign to the workers can be scaled independently of the internal API. I don't know if you noticed, but there's no emoji for the left arm. But the same approach still applies, right? It's the same application, different supervision trees. For the workers, we will only spin up the open part that will actually execute the jobs. So it will look like something like this, okay? Very similar to the previous one, but now we have different Tiger Worker pods that join the cluster again, and basically everything else continues the same. The user continues to establish their WebSocket connections with the Tiger API pods. The API requests continue to be served by the Tiger API pods, but we can allocate more resources to the actual pods that execute the background jobs. And this is very important because as an HR suite of products, we have moments in the month that we do like some heavy lifting. So this is important to have this kind of flexibility. Before we leave the architecture part, I want to talk to you about data architecture. Until very recently, we had very vanilla ecto schemas, but this posed a problem, right? Because our data team that was ingesting a lot of the stuff that we have on our main database were trying to transform it for analytics, forecasting, etc. And for them, it was difficult to understand, should I segregate this sensitive data? Should I truncate it? Should it be anonymized first? And they were trying to do as best as they could, but they didn't know exactly what they should do, right? So to solve this problem, we basically took a shift-left approach and extended our ecto schemas, right? This way, teams have the tools that they need to autonomously classify all the data that they own. This will allow you, for instance, to to classify in terms of security, data protection, and the one I'm most interested about is the anonymization approach, because with this in place, we will be able to say, oh, okay, this is, I don't know, an email, I should truncate it. This is date of birth, I should only allow the year to be shown, stuff like this. And it will be provided for free and as almost a single source of truth based on our ecto schemas. The downside of it is that it becomes a bit verbose, right? So to mitigate that problem, we basically have some helpers like the fields email that you see in line 11 that allow you to basically bypass the classification because it's using a common classification that we have. Let's now talk about compilation time pains. And I need water for this one. So, a big source of compilation trouble comes from transitive compile time dependencies. Okay, so here we have like a simple example that show what they are. We have a user module, a user role module, and a role module, and each module is using one of the others, right? So the user has a compile time dependency to the user role because it's calling a function on a module attribute. Whereas the user role has a runtime dependency to the role module because it's calling a function inside the body of the function. So the problem with this code, which seems innocuous, is that if we now change the role on the bottom, it will cause the user model up here to also be compiled. Okay? And when this situation happens in a code base like ours, it's problematic. In the docs, these transitive compile time dependencies are also called compile connected. Okay? You can use mixxref graph to see like the complete user dependency tree. And if you use the -- label compile connected, it will only show you the transitive compile time dependencies. So if you want to keep developers happy, keep this list very small, okay? In our case, we have a linter in place, which basically mimics what mixxref does, but with a more polished output and the ignored list. But yeah, this is important for you because it will reach a moment in time where the transitive compile time dependencies will be too many, okay? We first stumbled on this problem after introducing the OpenAPI specs library. So the library recommends the use of the operation macro to document your endpoints. With this in place, it will generate beautiful OpenAPI documentation for you, but it has a problem. So as you can see, like in line 10, we say that the responses will be an API docs.userResponse module. And so with this macro, we are just creating a compile time dependency between the controller and the schema module. So whenever the schema module would be changed, a lot of controllers had to be recompiled, okay? So fortunately for our use case here, the solution was very easy. Ditch the macro and do what it does in runtime. So basically, we just defined the get operation function, which was what the macro was doing, and we return the operations struct ourselves. Okay? This way, we avoid the compile time dependency, and docs, when they are updated, won't force any recompilation of the controller. In our quest to reduce the compile time pains, we also had to move most of our configuration entries to runtime. Okay? Remember that with 100+ folks working in the same code base, a configuration change is really, really common. So whenever you pulled master and someone touched the config file, it would force everyone to recompile the application from scratch. And so this was a major pain point. Fortunately for us, a big chunk of our configuration could be moved to runtime, so that's exactly what we did, eliminating the need for a full recompilation most of the time. When we were profiling our application, our compilation times of our application, one thing became very obvious, okay? I'm not bashing on OpenAPI specs, I swear. After profiling the compilation times, from all the 50 slowest modules to compile, like 99% of them were API docs modules, okay? So in this list, you see like the top slowest ones, and the green ones are API docs modules. So we clearly were onto something, okay? So the one on the top took more than 100 seconds to compile, right? The code isn't complex. It was probably waiting for something else to compile to be compiled. And this happened on my laptop, okay, this one. So we knew we were onto something here. The way we were using API docs modules could be improved somehow. And so this is what we had in the beginning, okay? So on the left, we had an API docs salary module that basically had to implement this behavior and needed to expose a single public schema function that returned the schema struct, okay? And on the right, we have the invoice data that has a property salary, and the property salary points to the schema module on the left. This is what the library suggests for you to do, okay? And it's very simple to get it to work. The problem, right, is that we were having like a lot of links, let's say, between these modules. And so when we talked with Jose about this, the hypothesis was that since the unit of work of the compiler is the module, we had a lot of modules just for these OpenAPI spec schemas, so there probably was contention with the parallel compilation while handling so many schema modules. So his suggestion was to basically, let's ditch the modules and instead try functions and see how it works, okay? So to test these hypotheses, we forked the library so that it could allow to obtain the schemas not from a module, but from a function. And this improved the compilation times of these modules by more than 20 times. So this exact same example that we had before, it's here. So instead of having separate modules per schema, we now have a big API docs module with a single function, in this case salary, that returns the exact same struct. Okay? And on the right, you pass a tuple with the module and the function. This was enough for us to see a 20 times improvement on the compilation of these files. We think the hypothesis was confirmed, right? By reducing the number of modules, we significantly improved the compilation time of the entire application. Let me now show you some of the things that we had to do to improve developer experience, and something that I think only pop up when you have a certain size. So what's the problem currently? The beam plus our application takes 17 seconds to start. Okay? This was a test that I executed just this week. And so imagine that for each time you want to run mixed test, you would need to wait 17 seconds. This is terrible for developer happiness. And so to avoid this, a colleague of ours introduced the X tests tool. Okay? With the X tests, you only need to start the beam once, and then it's ready for you to execute the tests. And basically, it provides the same API that we are used to, right? You can run execute tests for a single file, for a line, for multiple files, and it even has a test watch. So the same experience you have, you can integrate it with Vim, as I have it. But the important bit is that you only pay the 17 seconds once. It will recompile the application for you as well, so it's it's a godsend. How does it work? We define the XTests module on the .ex file. This file is run whenever you run EX, okay? And it mimics what the mixed test task does, okay? It recompiles the code for you if needed, compiles the test files that you want, and then executes the tests. So it provides an insanely faster, tighter feedback loop that we wanted. So I think it saved hours or days to the entire company. Finally, I think I want to mention the test diff that we have. Its goal is to allow you to just run the relevant test for your branch instead of waiting for CI to run the full test suite. And it will allow you to basically run the existing tests that were changed or that are new in your branch, obviously. But then it will also test the files, execute the tests for the files that changed, and then it will also run the tests that belong to the dependent files, okay? This is the important bit. The dependent files are files that you haven't touched, right? But somehow the compiler sees them as depending on code that you changed, okay? So to identify those dependent files, we use the mixxref graph with the sync. And this way, we can be more or less sure that if the mixed test diff passes, it should pass on CI as well. So once more, mixxref, I think the tool that keeps on giving. Use it if you haven't yet. Let me now talk to you about flaky tests. This is an example of a flaky test, right? So we are fetching stuff from the database. We are assuming a given order, but we haven't specified any order criteria. This will probably pass locally. It might pass in the CI, but it will probably fail somewhere in the future. And the problem is that Murphy tells us it will fail in the worst possible moment. So when you are about to deploy that hotfix, it will fail. So this is very bad because it basically halts the deployment for the entire company, so we need to prioritize fixing these flaky tests as much as possible. So what do we do to handle them? Okay, we've run them in CI with -- warnings as errors. If tests passed, we are done. If we have a return code of 1, there are warnings, so we also fail the build because warnings are bad. But if tests failed, we don't immediately wrap up, okay? They are flaky, they might be flaky, so we need to do a second pass, okay? This time we only run the tests that failed. If they fail, That's good in a way because they are failing consistently. You just need to fail the build. But if they passed, it means that some of them are flaky, right? So you need to create, in our case, we create a flaky report comparing the previous with the current execution. And then we create a linear ticket and notify the flaky test channel, tagging the person on the Git blame for the given test. This is very important, and like it closes the loop because the team then needs to prioritize this because they might be blocking a lot of other teams. And we are almost 50 teams by now, so there is a lot of people for you to block. Something else that we also had to tame recently were our CI logs. They were like very hard to understand, big wall of text, and so very spammy. It was impossible to use them to identify the tests that failed. So what we did, we basically bumped the log level of the migrate to info so that we didn't get these pesky debug logs that come by default. And we also bumped the log level of the XUnit, the capture log configuration, to critical. Okay? This controls the minimum log level that is used by XUnit to print the output in a test failure situation. So by increasing it, we reduced significantly the noise without missing anything. And so with this change, basically we got what we needed. Now it's much more easy to identify the tests that failed. And so like, it's a kind of a nice thing to have. I want to talk to you about observability. We obviously have logs, metrics, and traces, okay? We use OpenTelemetry for both metrics and traces. So in purple, you can see like the front-end application. In green, it's the monolith, the back-end monolith. But not only we have this, but given that we have a lot of teams within the same code base, it's very important for us to be able to quickly figure out not only what's happening, but also the responsible teams for it. So we collect the same data for open jobs. If we open one of these jobs, you will see the same thing. The important bit that I want to tell you about is like the team span attribute on the bottom. Okay, so every trace that we have, every span, has a team tag so that we can immediately and if needed, warn the team that something's off is happening. So if you see a span that is taking too long, a query that is taking too long, we use it to find the right team. How do we do it? We basically handle open events, sorry. This here is the open job start that open emits for us every time we start a job. Then we look for the team that is assigned to this worker, place all this metadata on the logger metadata of the current process, and then we start the trace, okay? This way, we will have the team tagged on the logs, on the metrics that we will emit, and then on the trace itself. To enforce that every worker needs to have an owner, we use our own remote open worker module, which is essentially a wrapper around the official open worker module, but it forces you to set an owner. So this way, we can be sure that everyone will assign their workers, okay? But this is all very good, but if you don't lint it, something might slip under, even during code reviews. So on the bottom, you can see like the validate worker assignments that we use every time in CI to check that no new worker is unassigned. For API endpoints, we do the similar approach, but at the controller level. So before the API request reaches the action function on the bottom, line 4, we basically pass the connection through the plug, which we called add team to observability context. And this ensures that the team tag is assigned to the current trace. Okay? The plug is very simple, so we get the current controller and action. With it, we try to find the team that is responsible for it, and then we basically set the attribute on the current trace. Okay, like we do for open jobs, we also have a linter to ensure that every endpoint, every route is assigned. Here, the pricing team owns these two controllers, as an example. And finally, about like ownership of errors. This is also very important because we want for teams to quickly own and react to the errors that we have. So before pushing errors to Sentry, we scrub the event from any PII. We then add the logger metadata that we saw that has already the team tag. And we also had some pen tester information because we have pen testers working with us, and some of the errors that they generate in the system are very peculiar. So we add a specific tag to warn whoever picks the investigation of the error. And then in Sentry, we have teams, our teams, all the teams there, we assign them, and we also use Sentry for like the actual route of the error notification to a given Slack channel, so that different teams react to it differently. The important bit is that they always have it in place. Almost there. Along this growth path, right, we mixed and matched different tools and approaches. I've already talked to you about Oban. Oban is a very important tool for us, so let me share with you some of the things that we learned along the way. Oban provides you a lot of telemetry callbacks that you can implement it, but you should keep like your handlers, telemetry handlers, very robust, because any error will detach the handler. So imagine that you have, in our case, we had an error while trying to assign a given Oban job, and it was detaching that handler for the given node. Then, for other errors that were happening, we weren't understanding why we didn't get the Sentry error. And so it was a painstakingly hard to look at the logs and try to understand that before the actual error, there was errors happening that were causing the handler to be detached. Okay, so please don't fall in the same trap as we did. Monitor the telemetry handler failure events, or alternatively, look for your logs if you have any has failed and has been detached message. This is a bad sign and you don't want to have this. Other thing that we had to do is that we were getting a lot of spam errors for stuff that failed once, but a subsequent retry would succeed. So to avoid these transient errors to be pushed to the team's channels, we are now basically only pushing Sentry errors whenever the attempts are exhausted. Okay? This ensures that, okay, we react to real errors, but we are not, we don't need to immediately jump on things that recover with a retry. Right? Retries will work if you keep your jobs idempotent, by the way. Remember about that. Also, Oban has a lot of engine-specific telemetry events that we weren't listening in the beginning, but they might become very helpful. So check the discard job events and log them. You might, when you need it, it's good to have them there already waiting for you, because otherwise it might be hard. Finally, Oban workflows. We use them a lot because they allow you to compose arbitrary sequences of jobs that will only run if their upstream dependencies execute. So in this case, we collect a payment, we create a bill run, then we apply the payments, then we emit product subscription started. So this job history of past jobs that executed is very important, okay? So think before pruning jobs. Oban needs that history to be present so that it can decide whether or not to execute a downstream job. Alternatively, if you really want to be aggressive with your pruning, you can use the ignore deleted workflow option that will basically consider deleted jobs as succeeded, and then it will execute your downstream jobs. If you are building reporting for pending jobs, don't look only at the scheduled at attribute, because for workflow jobs, they will be scheduled for the year 3000. So instead, if you really want to do that reporting properly, look at the meta attribute, the orig scheduled at. Otherwise, you will get very funky results and you won't be understanding what's happening. And finally, if a job fails that belongs to a given workflow, you fix the bug, you retry it, the job succeeds, you call it a day, That's bad, because the downstream dependencies won't be executed automatically. So this is a caveat that also caught us by surprise. Execute those downstream jobs afterwards, because O1 won't do it for you. To wrap up, I've highlighted some parts of our monolith while skipping many others, but trust me when I say we have been building a lot of cool stuff. So far, Elixir enabled us to scale our system and team, right, while keeping the monolith and the architecture as simple as possible. So the fact is that we have more than 100 engineers working on a monolith on a daily basis, and it's still working as intended. Definitely, there are definite challenges that we still face. So from time to time, we still see memory usage spikes. We see some database queries timing out when the system is under load, so we need to fix that. In terms of DevX, we can do better in terms of CI times, compilation times the test suite takes to execute, the time that a deployment takes to finish. But I think it's an eternal work, right? We need to always strive to have like the best developer experience possible. And as you saw, we adopted Boundary head-on, and then we kind of backtrack nowadays. So we have like now a mixed approach that people are more happy with it. In the future, I think like we might start to think about maybe splitting the monolith, right? To get like better compilation times, to reduce the context that each team needs to have, for product areas to start owning their data. So we haven't decided anything, but I think we can only take the compiler and the size of, with the size of a code base this size for so long. And we probably will need to start using more our read replicas. Currently, they are a bit underutilized, so I think this is probably a low-hanging fruit that we might tackle next. I want to thank all my colleagues, friends, for the great work they have been doing. I talked about a lot of stuff that I didn't build, so this was only possible because of them. Yeah. Thank you.